Hi everybody, and welcome back to Algebra. Last time we talked about pi, but today we're going to be talking about something a little bit different. We're going to be talking about square roots. Square roots, as I always like to explain to the kids I was teaching, is basically just a way to reverse an exponent of 2, right? So let's take a look at 5 for an example here. We've got 5. Okay. 5 squared, we all know, is 25. Okay. Now, if you wanted to somehow get back to this 5, if you wanted to reverse the exponent here, you can square root the 25, and that gives you 5. It basically is reversing, right, that exponent. Okay. It's kind of like multiplication and division, right? They're opposites of each other. Square roots are the opposites of these exponents of being squared. Okay. Now in algebra, we're going to be seeing all sorts of different square roots, and we might even see some variables inside square root symbols. But for right now, let's just talk about kind of the basics. Okay. Every number, every real number, has a square root. Okay, even the ones that don't come out nice and equal, like 25 here, okay, they have square roots. So for instance, right, you can square root, let's just go with 22, okay? Now this square root here, it's not going to give you something nice and equal like 5. It's going to be some decimal 4 point something, right? But it's still possible. You still are going to get a square root from this, right? There is a number, it's probably some sort of weird decimal, that you could multiply by itself to get to 22, and if you square rooted 22, you could figure out what that exact number is. Okay? Here's the thing though, in algebra you're going to learn that there's not always a positive square root, right? The square root of 25 is 5, we know that, okay? But it turns out that the square root of 25 is also negative 5. Negative 5 times negative 5 also equals 25, okay? So in algebra, you're going to learn that there are always 2 answers to a square root problem, a positive and a negative, okay? And we can write that easier by doing this. It's called the plus and minus symbol. So you put a plus over a minus, and then you get a 5 there. So that answer can be written much more simply as plus or minus 5, okay? There's one other thing that we can do with square roots that it's pretty useful. And what I like, it's like a simplification of these odd square roots, right? 22 is not a simple square root by any means, right? But it turns out that if you know what you're doing, you can actually take these square roots apart and simplify them. So let's look at a different square root. Let's look at number, let's say 24 here. Okay. Now, 24 is a factorable number. You can factor 24, right? Let's factor 24 real quick. If you factor 24, you could get 4 and 6, okay? Now, they're still in the square root, okay? What's the square root of 4? Well, it's 2. The square root of 4 is 2. And you can't really do the square root of 6, right? But 2 times the square root of 6 is actually the square root of 24. These things are equal, okay? So you can factor a square root and simplify it in this way. Let's do another one real quick, just so we can kind of see how it works one more time. Let's do 100 this time. So you have the square root of 100. If you factor 100, you can get 25 and 4. And those are both perfect square roots, right? You could square root 25 and you would get 5, and you can square root 4 and you can get 2. 5 times 2 is 10. And what's the square root of 100? It's 10, right? You can do this factoring thing and it's still going to get you the same answer you would normally get. So it's kind of a way to either simplify square roots that are different, or to find the answers to regular square roots, maybe if you forgot. Okay. The final thing that we're going to talk about is something that we talked about a little bit earlier, if you remember all the way back to when we had talked about like terms, okay, exponents can be considered a like term. So let's say you had 2 root 6 from our last problem plus 3 root 6 minus 4 root 5. Okay? These 2 root 6's here, they're like terms. You can add those root 6's together. You could add 2 plus 3 and get 5 root 6. Okay? This root 5, though, is not a like term. It's a different square root, so you have to leave that one alone. You can't simplify that anymore. So square roots can also be simplified in that way. And so that's an important thing to think about when you see square roots in an algebra problem. Okay? All of these things are very helpful. Okay? Square roots can be like terms. If you're simplifying, you can factor a square root to help simplify it further. And like I said originally, square roots are just the opposite of being exponented. And you can write an answer for an exponent as a plus or minus sign. Thanks for watching this video about exponents. Next time, we're going to start talking about perimeter and circumference. I hope you enjoyed this video and that you got something out of it. Have a nice day.